Welcome again to year 2026. I pray that this year is going to be favorable to everybody, specifically to my viewer and my subscriber. I pray that we are going to excel in this year 2026. Starting with year 2026 is simple linear regression. What is simple linear regression? The simple linear regression analysis shows the relationship between two or more variables. The variable that we are talking about is the response and explanatory variable. In this tutorial, I will be discussing about simple linear regression, although we have simple multiple regression as well. That is the regression that have one response variable and two or more explanatory variable. But in this tutorial, we're going to talk about one response variable and one explanatory variable. The simple linear regression shows the relationship between dependent variable and explanatory or independent variable. The dependent variable is equally known as response variable, while the explanatory variable is known as independent variable. Usually, these two variables x and y, they are denoted as x and y. The variable used in the simple linear regression is denoted as variable x and y, in which x is the explanatory variable and y is the response variable. That is, whatever happens to this variable x, the variable which this response variable will react to anything that happens to this variable x. That's why they said it call it response variable, because it responds to any changes in variable independent variable or explanatory variable. Then in this simple linear regression, there are a lot of concepts that is being used. Some of the concepts that is being used in the simple linear regression are: 1. Y represent the response variable or dependent variable. Like I said earlier on, the response variable is equal to a dependent variable, and x represent the explanatory or independent variable, and beta naught represent the regression intercept, and beta 1 represent the regression slope. All these concepts will be applied to solve the regression equation. Furthermore, in order to calculate the linear regression equation, we have to know all these formula and how to apply them. For calculation of the slope, we have beta 1 is equal to summation xy minus n into s bar close bracket open bracket y bar all over summation s square minus n into s bar all square. That is, this bar is the mean of the explanatory variable, y bar is the mean of the response variable. Or if we don't want to apply this formula, we can equally use this formula, or these two formulae they give us the same answer. That is, beta 1 is equal to n summation xy minus summation x summation y all over n summation s square minus open bracket summation x all square. We are going to apply this formula, these two formula, in order to show that they can give us the same answer. In order to calculate our intercept, we have beta naught, which I already said. The beta naught is the intercept. This is equal to y bar minus beta 1 s bar, and this is after getting the slope and the intercept. This is the regression equation that we are going to result as y is equal to beta naught plus beta 1 x. Now, these are the example that we want to use to calculate this simple linear regression. We have variable x, which is the explanatory variable or independent variable, and we have variable y, which is the response variable or dependent variable, with this following data, and we have the sample size 6, and our variable x is 2, 4, 6, 7, 10, 11. Then the total is 40, while our variable y is 6, 8, 9 up to last value here 4, which is the total sum of 41. Therefore, our variable xy, that is, we multiply x times y. That's why we got have this xy. And 2 times 6 giving us 12, 4 times 8 giving us 32, 6 times 9 54, up to the last value here 11 times 4 giving us 44. Then if we sum all these xy together, it's going to give us 258 as the total. And we need to get, based on the formula, we need to know our s square, that is the square of all these value. 2 square 4, 4 square 16, 6 square 36, then 11 square 121. The same thing y square, 6 square 36, 8 square 64, all to the last value here 4 square 16, giving all this total 297. And we are going to apply all these values to solve our linear regression equation. Then the next thing is to calculate this mean. Based on this formula, we are going to get s bar summation y all over n is equal to 40 all over 6, giving us 6.667, and we have to determine our mean of y, that is mean of the response variable, which is y bar is equal to summation y all over n is equal to 41 all over 6, giving us 6.8333. And in order to calculate our slope now, with this formula, the first formula, we have to summation xy minus n. Our n is 6 into s bar bracket close open bracket y bar all over summation s square minus n into s bar square. Then, having known all this formula, we know our summation xy to be 258, and our n, which is sample size 6, and our mean size for x bar is this, and y bar is 6.833 as it is shown here, all over summation s square 236 minus c, which is the sample size, into s bar square, that is this value 6.667 all square, are giving us minus 15.334 all over 59.33, and our slope is minus 0.2584. Now, or to calculate the slope again, to use the second formula, n summation xy minus summation x summation y all over n summation x square minus summation x all square. Then we are going to put in all the value in the table as shown previously, and it's going to give us minus 92 all over 256, giving us minus 0.2584, like the initial formula that we apply. So any of these two formula can be applied to solve the regression slope. Then we are going to calculate our intercept, and our intercept is beta naught. Beta naught is equal to y bar minus bx bar, giving us this value 8.5562. Then our linear regression, so far we have known our intercept now, so our linear regression equation can be written as follows: y is equal to beta naught plus b1x. Then we are going to slot in all this value, the intercept, which is this value, and our slope, this is this value, and it's going to give us this is the regression equation that we are talking about, or we want to calculate. Y is equal to 8.5562 minus 0.2584x. This is the regression equation. Now we want to interpret our regression equation. So for a unit change in explanatory variable, the response variable will decrease by 0.2584. That is, the response variable will decrease by this value. For any unit in this changes in explanatory variable, the response variable will decrease by 0.2584. Still repeating it. For a unit change in explanatory variable, the response variable will decrease by 0.2584. That is, whatever, if anything happens to the explanatory variable, the variable y, which is the response variable, will react. This is the what is going to react with. Then now, since the major essence of the simple linear regression, we can use it for predictive purposes, mostly in the data science. So now we want to predict the value for y when x is 13. Therefore, use the regression equation. That is, we are told to use this regression equation. this value that we already gotten, we can use it to predict our regression equation. So as it is, we are going to rewrite this regression equation that we show in the previous slide. Y is equal to 8.5562 minus 0.2584, giving us this. Therefore, we already know that our x is 13. So we are going to, whenever we see a, we are going to place 13 there. So our y estimate, that is our predict value of our y cap is equal to 5.1970. Then interpretation: when explanatory variable is 13, it can be predicted that the response variable will be 5.1970. Thank you for listening to this tutorial. If you find value in this tutorial, like, share, comment and subscribe to my channel in order to make my channel to grow and to enable the algorithm to push forward my tutorial.